So in this video, we're going to look at an application that involves absolute value inequalities. We're going to look at an application involving submarine depth. And this is going to turn out to be one of those OR style inequality problems, absolute value inequality problems. So what do we have here? It says the sonar operator on a submarine detects an old World War II subnet and must decide to deter over or under the net. The computer gives a depth model right here, where D is the depth in feet that represents safe passage. At what depth should the submarine travel to go under or over the net? Answer using simple inequalities. And by simple inequalities, it's just saying that you don't need to use, for example, interval notation, although we probably would want to answer in a complete sentence because it is a story problem. If we just draw a picture of the situation that's being modeled, we've got sea surface, right? This is sea level. So if I just think about what we're modeling, sea level is usually set to be 0. You set sea level at 0, feet in this case because we're measuring in feet. So it's going to be 0, whatever your distance measurement unit is. And then you define downwards typically to be positive. So at some depth below sea level, there's going to be this net that's impeding the progress of the submarine. And the submarine is going to need to either choose to go above the net, or the submarine is going to need to choose to go below the net so as not to become entangled. And then at some depth, there's going to be the ocean floor. So what we have is a depth model for safe passage. So the first step is to write the depth model. And then we want to isolate the absolute value sign. So I'm going to add the 20 to both sides. This is going to give 184. And we're going to have depth minus 394. Absolute value of that is greater than 184. And we want to notice we have a greater than symbol, which means we're in that OR situation where we get two solutions. We get something or something else with inequalities. And that makes sense because what you can see from the picture is we're expecting to get two inequalities. One that describes the submarine passing somewhere in this region above the net, and a second inequality that describes the submarine passing in this region below the net. So if we think about the physical situation, an OR model actually makes sense. So what we want to do is from this establish the two inequalities. It's a greater than model, so it's going to be an OR. So I'm either going to get depth minus 394 is less than the negation of this number, or I'm going to get depth minus 394 is greater than 184. One of those two things needs to be true. So for this one, we would add the 394 to both sides. We would get the depth has to be less than 210, and that's in feet. And in the picture, for the depth to be less than 210 feet, we're actually getting this bound on the model, right? Less than 210 feet means go above the net. And then we get OR. We add 394 to both sides of this one. We're going to get depth needs to be greater than, and that's going to be 578 feet. And this inequality is actually describing this region here. For the depth to be greater than 578 feet, we're going to be below the net. So here's two simple inequalities that are answering the question. And so if I were to put this in the sentence, I would just say the submarine needs to travel less than 210 feet, and that's below sea level, or even better, travel at a depth. That more nicely describes the situation. At a depth less than, a depth, D for depth, less than So I'm still describing it using simple inequalities. I'm just taking this inequality and putting it into words. Or at a depth, because that's what D represents, and there's the greater than symbol, depth greater than 578 feet. And notice how drawing the picture does actually help us visualize what the inequalities are saying. By simple inequalities, they're just saying, hey, you don't need interval notation. We could answer it in interval notation, and it's kind of interesting to think about it in interval notation. The depth would be an element of the interval. Well, the submarine, to be less than 210 feet, it could be right at the surface of the ocean, right? Submarines can do that. They can float on top. So the depth would go from 0 feet, not negative infinity in feet, because that's physically impossible. So interval notation here is a matter of looking at the situation and saying what's physically possible. So at a depth from between 0 and 210 feet, not including the 210, union, and then where would the next interval start? It would start at 578 feet. And notice it wouldn't make any sense to say, hey, they could anywhere from 578 feet to infinity feet. Well, that wouldn't make sense as a way to end this interval, because you can't go infinity feet below sea level. The ocean has a finite depth. So the other end of this interval, we would need to know something. Maybe we would need to know maybe how deep can the submarine go? Or if we know how deep the ocean is right here where the net is, maybe the ocean is 1,100 feet deep right here, possibly. And then we would say, well, if the submarine is constructed to handle that depth, maybe it could go all the way down to the 1,100 feet, but you probably wouldn't want to put it on the bottom of the ocean, so I'll do an open interval. So the issue with interval notation is we would need to know a little bit something more about the submarine, the water depth, the physical properties of the submarine, to put a lower bound on how low the submarine would be able to dive.